Now, here's the two skills I want you to learn very well. So coming up in chapter 2, you're going to be dealing with various graphs. This can apply to any graph. And we're going to have to learn how to draw a line between those 2 points. As you can see from this graph, this object goes up and up and up and up and then down and down and down. The distance between any 2 points is considered an average rate of change between 2 points. Let's look at how we're going to do that. It's very important to learn this. So here we have the 2 points, 2 comma 1 and 3 comma minus 6. And we want to figure out how to draw a line, between those 2 points. So from here down to here. And we want that line to sort of be accurate. We want to know the slope. Well, let's start with memorizing the slope formula. So first of all, the line formula we're going to be dealing with is mx plus b, but you might have to use multiple line formulas. And we're going to focus on m. M is the slope. Well, m is y2 minus y1 divided by x2 minus x1. And generally speaking, the x1 and the y1 should be the points to the left, should be these points. So we can see from this the x1 is 2 and the y1 is 1. And then the x2, y2 points should be the second point to the right. Always to the right. So if I label them, if I start by labeling them, by the way, this should be in brackets technically, divided by the other. If I label them, my x1 and y1 is 2 for x1, y1 is 1. And then down here, my x2 is 3, and my y2 is minus 6. And then when you're dealing with minus numbers, it's not a horrible idea to put all of it in brackets, because the numbers negative is different from these negatives here. These negatives are part of the formula. Okay, so let's just do y2 minus y1. y2 is minus 6. And y1 is positive, so we don't have to worry about it. It's minus 1. So it's minus 6 minus 1. There we go. And x2 is 3. And x1 is 2. So 3 minus 2. That just was a coincidence. Normally the subtractions are going to be harder than that. Minus 6 minus 1 is minus 7. Divided by 3 minus 2 is 1. And minus 7 divided by 1 is minus 7. So that means we have the slope of this line. In other words, it's going down 7 units for every 1 it's going to the right. But we want the line formula. Well, the line formula says I have the slope, but I don't have b. To find b, I have to use any point on the graph for x and y. And I should use the easiest ones. Well, the easiest ones here are 2 for x and 1 for y. And this is to solve for b. Suddenly I discover b is 15, which means my line formula is y is equal to minus 7x. So now I just bring back the x and the y and replace just b and m plus 15. And now let's confirm that in Desmos. I'm going to put the line formula right here. And sure enough, you can see that this purple line definitely goes through these 2 points, which means it is indeed, so I'll just turn off the red line to show you, it is indeed the correct line formula for those 2 points. This is an important thing to learn. So how to draw a line from slope, how to figure out the slope, and how to figure out b from any point on the graph. You're going to have to use that technique over and over again. There is another technique where you can use these 2 points to figure out the entire formula, but I'm going to save that. This is also going to be, that's called an average rate of change between these 2 points. So this purple line represents the rate of change between those 2 points only, not the whole graph. But now I'm going to ask you something. What about the rate of change between a point that is very close to this, just to the right of 2 for x? Well, a good example of that would be a point right to the right, 2.01. That's just to the right of 2, isn't it? But how do I find The y value, well, I'd have to plug it into this formula. Or I can let Desmos do it, but if I'm going to plug it in the formula, it's going to be minus 2 times 2.1 squared plus 3 times 2.01 plus 3. And that's really just plugging in the formula. And I get a y of 0.9428, which means I'm talking about the 0.201, 0.9498. I want you to notice that it's very close to my original point, isn't it? It's very close. They're so close together, it has trouble showing the difference. But now, we're going to find the slope for that point using the same techniques and the line formula. Oh, you might be tempted to say that line that already exists before, but that's just a coincidence. That's just actually, that's the slope of the graph coming through, like there. That's not the line formula, so don't make that mistake. So it just happens to be there. So I'll pull back to show the original graph, and we're going to use those two. Now we're going to find the line formula between these 2 points here, as shown on the graph in a bigger scale down here. And once we find the line formula and we draw the line, it's going to look something like this. It's going to look something like this. And even though it sort of matches the graph there, it actually measures the slope at that very particular spot, 2, 1. And this becomes important calculus, but I spend chapter 2 learning it. But anyway, let's go back and remember what the line formula is. M is equal, well, y is equal to mx plus b, but m is equal to y2 minus y1 and x2 minus x1 divided by x2 minus x1. And we got to use for x2 and y2, we're going to use the further right point, which is 2.01 for x2, and y2 turned out to be this. Okay. And then, of course, my y1 is still the 1, and my x1 is still the 2. So we're getting 2.01, sorry, we're getting 0.9498 minus 1 for this one. And down below, we're getting 2.01 minus 2. Notice that it ends up being the number that we added to the 2. That. And then up here, this is going to be a negative number. It's negative 0.05. Let's see. Got a 2 to that and a 1 to that. Yeah, there we go. That's the top divided by 0.01. And then with experience, you're going to discover that numbers divided by 0.01 is the same as multiplying by 100 rather. And we get that. So that is my slope for that point. That is my slope for that point. Now, what about figuring out B? Well, it's the same technique, and we're going to use the easiest points. And obviously, the easiest point is 2, 1, because the other one has a lot of decimals in it. So we put 1 in for the y, our slope here, 2 in for x, and now we're trying to solve for B. And we get minus 10.24 when we multiply it by 2. Then we add it to both sides, we get 11.24 is equal to B. Now we replace the m in our formula and the b. And we're going to plug this into Desmos to see how good it came out. Well, it came out very well, the blue line. It is cutting through the 2 points of interest right there, here, and here. And if ever you want to make sure that you indeed got the right coordinates, you could put in f of 2.01 and it should spit out your y. Oh, I have to make it g because I have an f of x up above. G. And I do indeed get 0.9498. So this is definitely the line for this instantaneous rate. This is called an instantaneous rate of change because it's 2 points right close to each other. And that blue line represents the slope technically at the point 2.1. And this becomes an interesting exercise. Now, you might say, well, what do you mean that's the slope? Okay, let's pretend that line wasn't there. If I climb up a hill, it's clearly hard going, right? Steep, steep, steep. And then as I get to the top, it's less hard. Then I'm standing at the top. And at the top, there's a slope of 0, which is at the very top. But then as I start going down, it's a little bit steep, a little bit steep, a little bit steep, very steep. And we're measuring at any one of these points how steep the hill is. Obviously, as we're going up, it's going to be a positive slope, and as we're going down, it's a negative slope. That's why we have a negative 5.12 for this graph. These two skills, slope between 2 points and then the line formula, and the slope between 2 points too close together, are called average rate of change for 2 points far apart and instantaneous rate of change for 2 points close, are skills you will need for this course.